Assalamualaikum and salam sejahtera. Chapter 4, Introduction to Organic Chemistry. This is lesson overview to this chapter. There are 4 sections: 4.1, 4.2, 4.3 and 4.4. We will focus on 4.1, which is molecular and structural formula. At the end of this video, you should be able to define structural formula, to show structural formula in the form of expanded, condensed and skeletal structure based on molecular formula, and you are to classify carbons into primary, secondary, tertiary or quaternary, and hydrogen into primary, secondary and tertiary. What is organic chemistry? Organic chemistry is the study of compounds of carbon. Organic compounds may contain hydrogen as well as carbon and other elements such as oxygen, nitrogen, halogen, sulfur, and phosphorus. There are well over 10 million organic compounds composed of carbon and other elements. Let's focus on hydrocarbons, which are organic compounds. Hydrocarbons can be divided into saturated hydrocarbon and unsaturated hydrocarbon. Saturated hydrocarbon contains only single bonds, whereas unsaturated hydrocarbon contains at least one carbon-carbon double bond or carbon-carbon triple bond. Carbon atoms can form single bond, double bond, or triple bond. For it has 4 valence electrons, therefore it can form 4 covalent bonds. So you can see that each carbon will have 4 attached bonds to it. 1, 2, 3, 4. 1, 2, 3, 4 attached to this carbon. 1, 2, 3, 4. Molecular formula shows the actual number of atoms of element in one molecule of compound, whereas structural formula shows how atoms in a molecule are bonded to each other. There are 3 types of structural formula, namely expanded structure, condensed structure, and skeletal structure. Let's look at the expanded structure first. Expanded structure indicate how atoms are attached to each other, but they are not representations of the actual shapes of the molecules. To draw the expanded structure in 2-dimensional formula is like this. So for molecular formula of C4H9Cl, we expand each atom. So there should be 4 carbon, 1, 2, 3, 4 carbon, and around the carbon there must be 4 attached covalent bond. And hydrogen, as you can see, only has 1 attached covalent bond because it has 1 valence electron. More examples of expanded structure. Draw for alcohol C2H6O. Okay, we have 2 carbon, so we draw 2 carbon. And then for each carbon, we must have 4 covalent bonds. Okay, so and we fill in with hydrogen atom. And one more, there is OH. Later on, you will learn that the OH here is the functional group for alcohol. Next, for carboxylic acid, there are 3 carbon here, so we draw 3 carbon, and each carbon must have 4 covalent bonds. Okay, and then we have, since it is carboxylic, so there should be C double bond O OH. So I need to erase one bond for this carbon so that we have 4 covalent bond for that particular carbon. So we fill in with hydrogen. So here you will learn later on that COOH is the functional group for carboxylic acid. To draw a condensed structure, we do not show single bonds between carbon and hydrogen atoms like we do in drawing expanded structure, but we show double and triple bonds. Atoms that are attached to a carbon are written immediately after that carbon. Look at this example. For molecular formula of C4H9Cl, we draw the condensed structure like this. More example of condensed structure. To draw this condensed structure of hexane, we will try to draw the expanded structure first. So we have C6, carbon 6, 1, 2, 3, 4, 5, and each carbon will have 4 covalent bonds, and we complete it with hydrogen atoms. Okay, this is C6H14. This is called expanded structure. Okay, to draw the condensed structure, we write out like this. Carbon 1, we have hydrogen 3. Second carbon, we have 2. Third carbon, we have 2. CH2, CH2. And finally, the last carbon will have 3. This is called the condensed structure. Okay. Second example, aldehyde, CH3CHO. So we have carbon 1, 2, 2 carbon. Okay, and then each carbon will have 4 covalent bonds. Alright, CH3, and then this is CHO for aldehyde. Aldehyde will have carbonyl group C double bond OH. Okay, this is we call expanded structure. So the condensed structure will have CH3, C double bond OH. This is the condensed structure. Skeletal structure shows only carbon skeleton. We do not write the hydrogen atoms, but atoms like oxygen, chlorine, nitrogen are shown. Look at the first example. So we count how many carbons there are. We have 1, 2, 3, 4. So to show the carbon, the 4 carbons, I will draw in a certain angle. 1, the first carbon, and the second carbon is like this. Third carbon, like this, and fourth carbon. So I draw in certain angle to show the carbon 1, 2, 3, 4, and then carbon 2 we have chlorine atom. Carbon 2, this chlorine is attached to carbon 2. Okay. Second exercise, we have 1, 2, 3, 4, 4 carbon in a cyclic. So I will draw like this. 1, 2, 3, 4. That's it. To describe how atoms of a molecule are arranged in space, we can draw the structural formula using 3 dimensions. We can make use of wedge, dash wedge, and line formula to draw in 3 dimensions. For example, for this molecular formula, for this molecule CH3Br, we can draw either like this, or this. Notice that the line represent bond that lie in the plane. The dash wedge represent the bond that lie behind the plane. And the wedge represent the bond that project out of the plane. Class of carbon. There are primary, secondary, tertiary, or quaternary carbon. 4 class of carbon. It depends on the number of carbon neighbors. Number of carbon attached to it, neighbors. Jiran. Yeah. So if it is bonded to one carbon, we call it primary carbon. 2 carbon, secondary carbon. Bonded to 3 carbon, we call it tertiary carbon. Bonded to 4 carbon, or we have 4 carbon neighbors, we call it quaternary carbon. Hydrogen can be classified into primary hydrogen, secondary hydrogen, or tertiary hydrogen. There is no quaternary hydrogen. How to classify hydrogen? It depends on the type of carbon atoms bonded to it. For example, this carbon is primary carbon. How do you know it is primary carbon? Because it is bonded to only one carbon. This carbon, one carbon neighbor. Okay, so it is primary carbon. So the hydrogen attached to this carbon, is called primary hydrogen. So this is primary hydrogen, and also this is primary hydrogen. For the carbon here, this carbon is also primary carbon because it is bonded to only one carbon. It has one carbon neighbor, so it is primary carbon. So there are 3 hydrogens attached to this particular carbon. They are all primary hydrogen because it is attached to the primary carbon. You can study this structure yourself to see the class of carbon and class of hydrogen. In this exercise, you are to classify carbon and hydrogen and count how many there are. For example, I can see that this carbon is quaternary. Another quaternary carbon here, quaternary. This carbon is secondary since it has 2 carbon neighbors, and hydrogen that are attached to it is secondary hydrogen. This is also secondary hydrogen because it is attached to secondary carbon. Let's look at the answer. Try on your own and check answers. Check your answer. In this exercise, you are to draw either expanded structure, condensed structure, or skeletal structure. Check your answer. More exercise on drawing skeletal and expanded structure given condensed structure. Try on your own and check the following slides. To summarize, in this video, we have learned how to draw structural formula, namely condensed structure, skeletal structure, and expanded structure. We also learned how to classify carbons into primary carbon, secondary, tertiary, and quaternary carbon. And finally, we learned how to classify hydrogens into primary, secondary, and tertiary. That's all. Thank you.